All right, I think we'll go ahead and get started. Welcome, everybody. How was the keynote? I thought that was pretty awesome, sitting through that, and very valuable use of my time. I'm Ian Philpot. I'm a software engineer at Microsoft. I work with our product teams, not for one of the product team. I'm basically their feedback loop, right? We run investigations on software that we haven't even really released into preview yet, with some customers who are willing to really feel the pain. For instance, next week I'll be in the middle of Nebraska doing stuff with Windows containers on Kubernetes. And then we'll be going right back to the Windows team and the AKS team and saying, here's our findings. This is where we need to kind of adjust and that sort of stuff. So that's kind of what I do, where I come from. You'll also see James up here. James is one of my colleagues. He's also a software engineer and happens to be a bit of a bot expert. This talk isn't going to be all about bots, but I did utilize him because we wanted to do some of the stuff that's in V4, and he's already run a few things with customers using V4, which I think they're announcing private preview or public preview or something like that at Build this week. And then I'll turn it over to Nanu.
Thanks, Ian. Hi, everyone. My name is Anu Prasad. I'm an Azure Solutions Specialist. I'm also based out of Atlanta, not on Ian's team. I actually work for, I'm part of the sales organization in the Southeast. I work with large enterprise customers, helping them build solutions in Azure. And this is my first time to St. Paul, so really happy to be here, and welcome to our session.
Excellent. All right, so let's get on to it. The code for this, there's quite a bit of it, is right here. This will take you to a GitHub repo for NDC, and it's got everything from bots to Spark, Python notebooks, et cetera, in here. So that's where all the code is. So get your phones out, take a picture if you want, or if you've got your computer out, go ahead and browse over there. I don't know how well you'll be able to follow along. There's a lot of content. We're going to be moving pretty quickly. If you're interested in a specific area of this, please feel free to stop by afterwards, and I'll fire up the laptop at our booth, and we can dive into a specific area of it. We'll ask that you hold the questions till the end as well. Because there is a lot of content. We're going to be going from the edge all the way up to actually making use of the insights that we derive from this. So there is a ton of content. Can't say that enough. But for that, I'll go ahead and turn it back over to Anu, and I'll be running most of the demos.
Thanks, Ian. All right, so like Ian pointed out, there's a lot of content. What we tried to do was stitch together a nice story for you where we can kind of highlight some of the concepts and then show you demos. So be patient with us as we do a little bit of the balancing act between the two, right? So with that, just to set some context here, right? This is what we see. The world's basically changed. Okay, you see new technologies coming up every day. You see technologies disappearing every day, right? And if you think about it, every single industry is being disrupted. Look at what's happened to retail, right? And ultimately, it boils down to customer experience, right? Organizations care about customer experience because that helps them drive their top-line revenue. That helps them stay in business, if you think about it. The technologies that we've handpicked for this demo, IoT, bots, cognitive APIs, they all align with that technology, with that premise, right? So the best technologies are the ones that integrate into your main life, right, and become a part of your life, and they disappear because you don't notice them anymore. Think about your mobile phones. 3 billion connected devices and mobile phones, right? 9 billion microcontroller units are shipped every year. They're all embedded as part of toys, appliances. Connected appliances help with connected experiences, right? And those are good for customer experiences. Moving on to bots, right? if you think about it, messaging apps like WhatsApp, WeChat, all of these have surpassed social networks now in terms of number of users. And what some of these companies are doing is they're leveraging their existing customer base to actually span out into new business models. And I'll give you one example, and then we'll move into the next slide here. But think about what happened with Alipay and WeChat, right? Alipay used to be a monopoly in China, I think back in 2014, right? And then WeChat had 1 billion users. Just a chat channel, it was just messaging, right? But what they did was they launched this thing called Hongbao, which is a digitally charged envelope. It's called red envelope in Chinese, right? They launched that, and almost within the year, they were wedging their way into monopoly. So Alipay came up with the same idea almost immediately, but it was too late, because by the time they built it, it took time, right? So I just want to highlight the context of the world that we're living in, and with that, let us show you, our specific use case here. So we picked this architecture because it kind of touched upon all of those technologies that I just mentioned, right? In our use case, we wanted to use IoT to help save lives. Grandma is wearing a device. Unfortunately, she has a fall. She's alone. She's at home alone. Who finds out about it? The time that it takes for help to arrive is going to determine her quality of life after the fall, if you think about it. And so in our use case, what we did was we used an edge device, and we simulated that on our computer. And it's tracking grandma's accelerometer readings, right? So it's tracking how her movements. If she has a fall, it detects that anomaly. That anomaly, all that data gets fed into an IoT hub. From the IoT hub, we have a Databrick cluster, and we'll be showing you all of that shortly. The Databrick cluster picks up the anomaly as it happens, and then it pushes it into an event hub, and then an Azure function picks that up and triggers it off via a webhook into a Teams site where the call center operator gets a notification, is able to dispatch help immediately. So we're going to show you pieces of that, and we show you a demo at the end. With that, let's dive into why IoT, and let's just dive a little bit deeper into this before we show you the demo, right? So this was our use case with grandma's fall, right? But if you think about it, IoT has been around for like, what, 30 years now? And why is it so important now? Because it's becoming more mainstream. It's one of those technologies that has disappeared into our lives, right? It's available everywhere. It's in the things we use. It's around us. It's surrounding us, right? So if you think about that, IoT is used in manufacturing. Kohler actually has this concept of a smart bathroom, where your bathroom knows who you are, plays the music you like, adjusts the temperature of the water you like even before you step in, right? So the concept of creating these connected experiences is what you need to leverage these technologies for. So when you walk out of here, think about what can you do to leverage these technologies to create those connected experiences. Ian? Okay, so just some concepts around the IoT side of the house, right? We talked about the IoT device and the edge device. Yes, there are two types, right? The IoT devices have been around forever. They're just, I wouldn't say dumb devices, they're just devices that send data back to the cloud, right? The IoT Edge device actually helps you drive intelligence right on the edge. It helps you do the analysis on the edge and only send deltas or consolidated results back. So it can deal with intermittent connectivity issues. It can deal with low bandwidth. Think about oil rigs where you don't have a great internet access, right? So that's where you can use the edge devices. The edge, what makes an IoT device an edge device is the IoT Edge runtime that runs on the device. And the IoT Edge runtime is made up of two components. One is the IoT Edge Hub, And the second one is the IoT Edge agent. The IoT Edge agent monitors all the modules that are running, make sure that the device is healthy, everything's running as expected, and then the IoT Edge agent, IoT Edge Hub, that's a mouthful, actually communicates with the IoT Hub, which is hosted in the cloud, in Azure Cloud, and helps establish that connectivity, helps establish that security, right? And once that's secure, it creates a device twin on the device. So let's say the connectivity got popped off for some reason, it can continue to function as normal, and when it comes back up again, it can send the cached data back to the IoT Hub. The IoT Hub itself, think of it like an air tower controller in an airport. It knows all the, if you were sitting in that controller room, you would know what are all the flights that are coming in, who's going out, who's coming in, who's scheduled to do what. That's what the IoT Hub is for all the devices. It can manage billions and billions of devices, and it communicates with all of those devices. It can enable two-way communication, so you can push data down to the devices, make them do things, or receive data from the devices as they send you information. It's also responsible for monitoring, making sure everything is working as expected. Good so far? All right.
Cool.
So let's see this in action.
So I'll jump in. I started working with the team. I don't need that. I started working with the team, I don't know, last July. We were very much in private preview. Most of the stuff was undocumented and whatnot. So it's been an interesting journey for me, working directly with IoT Edge for a while. So let's go ahead and kind of take a quick look at this. I should have it running on my machine. IoT Edge control is our command line tool. This is changing a lot. They just announced, I believe, GA and everything at Build. So there's been a lot of announcements going on. But essentially, like Anu said, the Edge agent is sort of like its own little orchestrator running within Docker. So all of this does run in Docker. And I'm going to go ahead and turn this on if it's not already turned on. I should have run a couple of these commands previously. But anyway, the IoT Edge control is where we actually interface directly with our modules and the device. So the idea is that there's a set of certified devices that we have that can run the IoT Edge runtime. And essentially, it's a Linux box that's running Docker, right? So you've got Raspbian or something like that on a Pi, whereas you have IoT Core with Windows containers on the Windows side. And I have actually done some work. I had a customer that really did want to use Windows containers. I was like, okay, never done it, but let's try it. And it was pretty interesting. So just to get this running, I'll just say IoT Edge CTL start. And that's basically what you want coming from like an OEM. So it should be flashed and already all of this stuff set up on your device. I've worked with a couple of customers already where they have a custom board manufactured that they're putting on their manufacturing floor. And it comes with this setup. They run that command. And basically, it starts communicating between the local device and Azure. So if we do a Docker PS, we should see 3 containers running right here. I don't know why my machine is slow. I guess because I'm running Windows today. And you see that we have the Edge Hub, the Edge agent, and the accelerometer simulator that we built for this particular demo. So to take a quick look at the code for this, this is what it looks like to have a module. So if you see over here the different components of this, and the workflow for this is essentially you create a .NET Core app or a Python app or a C module, and it's it's a pip package if it's in Python. It's a NuGet package if it's in C#. So we're showing off C# here, obviously. And the idea, a couple of pieces that I want you to note here in our code. So this is our accelerometer sim. Basically, you enter main, and it sets up some of the connections. It calls init, that sort of thing. And really kind of what we're interested in here is the init method and a couple of things where we're setting up MQTT. I believe when we go GA, we will support AMQP, which, you know, arguably is a better protocol. But for now, right now in public preview, we only support MQTT. And we create our new hub client. So this is the actual SDK that's going to be talking up to the IoT Hub. And what we do is we register a desired property update callback. I'll get to that in a second. And we also register, where is it? Here, let me look at my, right here. We're calling send Excel message whenever a message is received from any kind of device. Or let me rephrase that. If I was to be receiving any kind of messages into this module, so these modules can receive messages and send messages, or both. This one's only sending messages, so we don't have, I'm not registering any inputs on this, right? And that's where the Edge Hub comes into play. It's kind of like having a nice service bus running directly on the device, where you can start receiving data from a device or a sensor, and then you run it through an entire pipeline that can even include machine learning modules and things like that. So the first thing I want to look at is just the send accelerometer message. And I really did try and dumb this down. I do have code up in the GitHub repository that actually pulls in real accelerometer data and that simulates a fall. If you're more interested in actually seeing it with real data, we can look at that in a little bit. But for demo purposes, we're keeping it easy. And essentially right now, we're sending a Y value of 0.5. And then when a fall happens, we send a Y value of 0.1. That's going to kind of trigger our fall. And it should sort of simulate exactly that. So we see that we have this fall Boolean here. And we're triggering that, and we're changing that using the desired properties updates of the module twin. So when we get into that, let's actually take a quick look at Azure for this. We'll come into our IoT Hub. I realize you might not be able to see this screen that well. You don't really need to. But in the IoT Hub, if we come down here, you'll see this IoT Edge preview. And this is where our devices are registered. So the device twin essentially represents the device in the cloud. It handles its ID, and it also handles what's running on the device as well. So if we go in, we have this one Contasso device that should be sending messages. And very simply, down here at the bottom, you see that these are the modules that we wanted running when I pulled up Docker and showed you what was running in Docker as well. That's where that all kind of places in. But you also have this device twin or module twin, and I'm really kind of focused on the module twin. So if we go into set modules here, and we look at the accelerometer data, and we have these desired properties right here. If I go in here and I set fall equals to true, that's what will simulate a fall. But I don't want to do it through the portal. I want to do it through the Azure command line. And that's where my thing script comes into play here. On line 18, you see this AZ IoT Hub apply configuration. This is where we get into a little bit of the DevOps practices. I'm kind of using it as a thing to trigger a fall. But essentially what this can do is it can redeploy new modules, different modules to the device. It goes, talks to the hub, tells the hub, hey, this is the modules we want running. These are the desired properties we want on those modules. And that hub then ships it down to the device. So that's kind of what we'll be simulating here today when we get later on in the talk. All right, so I'll turn it back over to Anu and our demo. our slide deck.
All right. Thanks, Ian. So, so Ian just walked you through how the device is going to push an anomaly, right, into the IoT Hub. This next piece has to do with the intelligence around it, right? So we have a Databricks cluster. I don't know if you guys have heard of Databricks, probably have. Okay, great. Databricks is essentially a PaaS offering in Azure. I believe we went GA earlier this year. I think it might have been in March. And essentially what it is it's running Apache Spark in Azure without you guys having to worry about how to do the cluster, how to do the networking, how to do the upgrades on the underlying infrastructure. So we leveraged a Databricks cluster here. We wrote up some script to detect the anomaly in the fall, right? So when that Y coordinate reading, changes from 0.5 to 0.1, the Databricks cluster basically picks it up. The Databricks job picks it up and says, oh, there's an anomaly there, and it takes that reading and pushes it out into an event hub, and then we have an Azure function that's polling the event hub to detect that and do something with it, right? So we could have done it a little differently. We could have probably used an event grid here, but this is kind of how we did it for this this POC. You guys feel free to take the code and modify as you see appropriate. The one other thing I want to mention about Databricks is, and this was actually something Ian pointed out, was it's really good with watermarking. So so if you have like events that are coming in from your telemetry that are out of order, then Databricks is smart enough to say, oh, you know what, these events need to kind of be processed in the different order, or if it has Windows functions. So again, I would encourage you guys to go play around with that as well. And we'll show you how we did it.
All right.
Over to you, Ian.
Excellent. Okay, so to a news point, we do have a Databricks cluster running up here, and I do need to get that started. So essentially, it's very simple. You go in, you say, give me a Databricks cluster, and it deploys into Azure for you. And you go in, you click, and you enter the workspace here. This is one of the notebooks that we're running. But I do need to go ahead and start the cluster that I have going. But let's take a quick look at what this cluster is. There's a couple of different types of clusters. There's the serverless pool and the standard pool. The serverless pool is exactly what it sounds like. It's more like the worker role type of thing. It's a VM that can go away and disappear on you under the hood quite often. So you're not going to be writing anything to the file system. The Databricks file system, you're going to be wanting to use more like blob storage and things like that when you're dealing with that serverless pool. You'll notice that it's in beta right now, and it supports Python, but last time I ran there, it didn't actually support Python, so I switched it over to standard. And one of the great things about this is there's a few different types of machines that you can set up here. You can set up auto scaling. I have all of that turned off. I had it all turned on for you guys. It was pretty awesome. But then I started getting calls about how much it was costing me. It wasn't a whole lot. I don't have a lot of money on my account. They kind of keep me under $750. And I literally stood up like a DS13, like 8 of them, which costs a lot of money. And I was getting very close to my $750 limit, so I was like, oh, let me back that down a little bit so that I can actually demo something. So depending on what type of workload you need, of course, you can scale it around however you want and pay as little or as much as you want here. So this is pretty great. I'll just come in and I'll go ahead and click Start, so we go ahead and have that running. I probably will not be able to launch the notebook just yet. But let's jump in and take a look at the notebook. We'll come into the workspace and look at the actual NDC notebook here. Now, this is a very bad practice. This is one of the areas that I didn't get to cleaning this out. In the real world, there's what's called a notebook workflow within Databricks, where you can have notebooks call other notebooks, and right now, that's the right way to store your secrets, right? So you store your secrets in a different notebook, and you execute that notebook from within this notebook, and it brings it into context of this notebook. That makes sense? I didn't get a chance to get to that. I meant to this morning, but I got busy. So anyway, we stand up a connection string. Now, this is one of the interesting parts here. This Sabi out of Redmond, he came out and hung out with me in Chicago not too long ago when I was working with a couple of different customers doing some of this data processing. And he wrote the code for the connector. This is the Event Hub's connector, right? And as you're looking through this, it's all in Scala, and it's Maven packages and things of that nature. But what's really nice is that he does surface it into the Python SDK as well, so you can use this from Python or Scala. I'm not sure about R, honestly, but this is where you'd come and get some of the instructions to set up a connection to an IoT hub or an event hub, or both, in our case. So back to our notebook, it's very straightforward. As this comes up, basically, we call read stream, and then we pass in the event or the IoT hub connection information and load. Pretty standard Spark code there for structured streaming. And data stored in an IoT hub or an event hub is binary encoded. So we need to go ahead and cast that into a string, and we're sending up JSON data. So we're going to go ahead and build a data frame using that JSON data that we can work with. And then we're just basically doing a very simple filter here, and we're filtering out everything but the point ones. Once we find the point ones, then we're dropping that into another event hub right here. So this is our output event hub. And same thing, only we're doing write stream instead of read stream. And it does do checkpointing. So this is one of those areas where if you're wanting to checkpoint, this is writing directly to the file system. Also why I didn't want to use a serverless pool. But if you wanted to, you could write this checkpoint document out to blob storage. Now, essentially what this checkpoint document is doing is it's using the event processor host underneath the hood for event hubs. And as it reads through the queue in the event hub, it's checkpointing where it's at. So if you stop the stream and then you start it back up, it'll start where that checkpoint is. It also allows us to scale over multiple streaming units under the hood with Databricks, so that when this comes up, it's reading from partition X at this checkpoint and partition Y. We bring another server online. It says, hey, I want partition Y. Where are you at in the checkpoint? I take that lease and start reading off of partition Y. And then that's how we can scale Databricks under the hood. Let's see if I can actually attach to the cluster yet. No. Once this gets up and running, I'll go ahead and start the notebook so that it starts catching up. Right now we're writing a lot of data from my Edge device, which just happens to be my Surface book here. It is writing up to the hub right now, so we're going to have to catch up, right? And then hopefully this will get started and caught up as we go through the next section. The last piece there I can show you in the portal is just the event hub. Not super exciting by any means, but we do have the event hub right here. So it's just an event hub namespace. Within the namespace, I have an event hub. And pretty useful little tool here, because we can watch when the messages get received by this. We should only get one message received by this event hub. Right there. All right, I believe we're good. Oh, last piece, the function. Yes. Now this was fun. I pulled in Joe Rayo. He's one of our serverless guys, and I was just kind of talking to him about Event Hub triggers and actually doing this as a C# class, not in the portal, but from within Visual Studio or Visual Studio on the Mac or whatnot. So what we have here is just an Azure function sitting there watching the Event Hub, okay? And once something drops on the Event Hub, this will trigger, and actually push out to Microsoft Teams. Now, one of the interesting things here is we're using a singleton pattern on the HTTP client. This is one of those kind of things you run into when you're really at scale, when you've got 11,000 stores online and you have functions driving some of your IoT lambda-based architecture, and all of a sudden your functions start taking 80 seconds to execute, and you're like, why is that? It's little things like this right here. Don't new up an HTTP client for every message that's coming in. Create a singleton because it can handle that singleton. It's safe to do that. HTTP client is safe to do that. And then it just opens up a connection pool and uses that same connection pool for the life of the function, which is great. And it speeds everything up, but there's also a little thing called DNS, and it gets cached within that connection pool for the life. So if your DNS changes, then you could have another problem where you're making calls to a server that doesn't exist anymore or something like that. And when you're using serverless-based architecture, DNS can change quite often, right? So one of the ways we figured out how to get around this was we truly did create a singleton here, and then going into the service point manager, we grabbed the URL, and then we set a connection lease timeout on that URL to about 60 seconds. So it times out the connection pool, flushes the DNS cache, and then redoes the iterative DNS query so that you always have the real DNS within 60 seconds. Okay, so it's just one of those little kind of tweaks that kind of bites you later on when you're actually at scale doing this. So that's already deployed, sitting there waiting to pick up from the Event Hub. So I'll go ahead and turn it back over to Anu, and hopefully I can start our Databricks.
Thanks, Ian.
Yep.
So, yeah, small little changes, right? Small little tweaks can help you get better performance out of this. One other thing I believe I forgot to mention earlier on is, with the Databricks, as you enable the auto scaling and the auto termination mode, be careful if there's a job running under the hood. It's not going to terminate, so just be watchful for that as well. All right, so we'll dive into the third section, which was we've talked about things, we've talked about how to get insights. Now let's make it actionable, right? Let's get that call center operator to be responsive. So that's where we used a bot. This is a pretty cool picture, I thought, but basically bots are nothing but pieces of software, right? Think of them as something that you would do to automate routine tasks. So they're great for conversational purposes. They can be made intelligent by leveraging cognitive APIs. But on their own, they're just simple, small pieces of software that you can go deploy via various channels. So these are the 4 common patterns that we see bots be deployed in. Okay, they're great for information retrieval. So think of them as knowledge KB bots, right? The LA County actually implemented a bot called Chip, and what Chip does is it fields routine questions that that the county used to get. Where do I find my I don't know, driver's ID? Where is the closest office to go take a DUI test or something of that sort, right? But you get the idea. So Chip actually reduced email traffic to the agents by 50%. Okay, so their agents were able to scale and do other things. Okay, another Ian.
Sorry, just making sure that's running.
Sorry, no worries. Another option where bots are good is transactional purposes, right? So think of these as book me my ticket, flag me my ride, right? So Uber actually has a bot that you can use to flag down a ride. I believe Taco Bell has a bot that you can use to place your order. It has a quirky voice, I've heard. I haven't used it yet. And then in an advisory role, right? In an advisory role, these are great for retail. As part of my current role, I work with a lot of retail and CPG customers. Advisory role bots are fantastic to help reduce friction at the customer service desk. because they can help you locate things in stores. Macy's has a bot that you can use to locate, where are the shoes, or where do I go find a matching purse, or whatever, right? And then I believe FedEx and UPS have got bots that'll tell you, where your order is, so it can give you information as it pertains to you. Now, we did talk about the bots being intelligent. A lot of these bots can be made intelligent, where they can actually detect emotions, detect context, and facial recognition in some cases. And so again, that has to do more with the cognitive API side of the house.
One quick thing, the advisory role is one that we're seeing quite often. I just worked on a bot with James, kind of in prep for this. I hadn't seen bots since like V2, and I wanted to see what V4, and he's been working with the team a lot. So I went out to a gig with him, and it's a company called Think of Us, and what they do is they help foster kids as they grow up and out of the house. They help them get prepared for life. And one of the ideas was that they want to surface a bot on their website where they can actually chat with that. And when it opens up, we had to do some kind of kung fu to get single sign-on to work with the authentication of the bot, because they're using Azure B2C. And which is really interesting. If you're interested in that, let me know. We did some back channel stuff instead of actually hosting it using the web channel. And one of the really cool things is it starts up, it looks at kind of their checklist and says, okay, what have these students or these young men and women not done yet that they should be doing, like getting a mentor, working on a budget, finding a place to live. And as the bot comes up, it surfaces that directly to them. When they say hello, and it says, hey, John, how are you? Hey, I noticed you haven't done a budget. Would you like to? And then we start going down that topic if they wanted to. No, I need to talk to my mentor now or something, And it kind of has that conversational feel to it. It's very impressive. I was, to me, it doesn't, I've been doing this for 20 years. Bots were fun in IRC channels back in the day, that sort of thing. But I don't turn to a bot first, typically. Like, I don't think, oh, I want to chat with a bot. But some of the younger generation coming up, they do. That's one of the first things. They're like, hey, where's the bot? Can I talk to it? And they do actually enjoy as some of these become intelligent. So how do we make them intelligent? I'll turn it back over to Anu.
Yeah, so for the intelligence part of this bot, what we did was we leveraged something called LUIS, Language Understanding Intelligence Service. We could have used, there's a plethora of cognitive APIs that you can just simply plug and play. But for this POC, we used LUIS, and essentially, this is the underlying concept of LUIS, right? So I would like the latest stock value of Microsoft. That's what the user types or speaks to, to the bot via a Cortana skill, right? We don't have Cortana in our bot, but they could, you could, right? And then what would happen is what the user has said is what would be classified as utterance, okay? What the program interprets it is what is your intent. So when the user says this, the program's interpreting it as, get latest stock value, right, internally. And then Microsoft here, which is right underneath the entity, entities, think of them as variables in an algebraic equation. You could replace that word Microsoft with pretty much anything else, United Health Group, Amazon, just pick your favorite, right? And at that point, that the bot knows that it needs to apply that utterance to that intent and that entity. Does that make sense? Okay.
Been doing some ML and data analytics with some of our customers, and one of our engineers out on the West Coast, we were working with a customer here, and they had a lot of data that had not been marked, right? It hadn't been classified or anything, and she did the most brilliant thing I was like, wow, yeah. She used LUIS to figure out the intent and actually classified all of the data so that we could use it as training data. And I just thought that was brilliant. Instead of hiring, a whole team of interns to go through and read a bunch of tweets and say, oh yeah, this is positive, this is negative. She actually used Lewis to do that instead. So there's tons of uses for this, not just within bots. And I thought that was brilliant.
And I think at Build, they just announced something around the fact that we're actually publishing now pre-trained models in some cases. So that was a pushback that I got a lot.
The AI marketplace,
Yeah, from my customers saying, you know, well, we don't have enough data to train this, and so it's pretty good if you can get some pre-trained data and then, you know, kind of build upon it. So we leverage the bot framework. This is Microsoft's way of building out a bot, right? And we leverage the bot framework for that. So if you were to look at this architecture, look at it in 3 parts. On the far left, you've got your bot, your web app, or your app, your piece of code that's running, right? On the very far right, you've got the channels you want to surface your bot through, right? We leveraged Teams to interact with our bots, but honestly, if we wanted to, it was just a simple check button, and we could have plugged that into any other channel, right? And the bot connector is the glue that kind of ties the two together. It helps manage session states. It helps manage, you know, your routes, you know, how your messages are being routed to the different channels. Maybe if there's like intermittent connectivity, you know, it has the intelligence to kind of handle some of that back end. And then the other thing, you know, when you're thinking about best practices for bots, and when you start applying it to cognitive APIs, think, you know, practically, how would this cognitive API be used with this bot, right? So once you build out your bot using this bot framework, think about how you make it intelligent. Maybe you don't want to use a text-based bot to play Halo, right? Or you know, just think about what it is that would, you know, make your bot intelligent. So with that, I think we were up for a demo, right, Ian? Did our cluster start up?
I believe so, yeah.
Okay.
So we're going to jump in to the demo. Let's go ahead and do that. It looks like we are receiving data and sending it. We probably shouldn't be getting anything in the Event Hub just yet. And I need to open Teams. I do have Teams open. Disregard anything that you see here.
This is our internal team, by the way. We built out a lot of the stuff together, so there's a lot of back and forth. We just leverage the same thing. We're like, okay, yeah, there's nothing secret in there.
What?
Except me calling Ian names and stuff.
Oh, Teams.
Maybe you can show one that we already had the message out and then show the webhook.
Well, Teams just is, my computer is not happy right now. Remember, I have IoT Edge sending a bunch of messages at the moment. So let's see if I can get this to pop over. All right, we'll leave that going for now, and we'll explore a little bit about the bot. Where is the bot? Right here. Okay, so as we come into the bot, let me make sure that's where I want to go first. Yes, it is. So as we start exploring the bot, this is V4. A lot has changed in V4 with the SDK. A lot of it, I think, is for the better. So basically, what happens is we come in and we open up main bot here. And to get this, you have to go out to the GitHub repo and actually compile the DLLs at the moment. There's no NuGet pack, or the NuGet package is so old at this point, it's basically useless. Everything's been renamed from like subjects to topics and all of this stuff. So if you want the latest bits, go out, grab the SDK from GitHub, download it, and build it. I also published the bits in the repo, so I went ahead and did an exclusion in my gitignore and published these DLLs there as well. So you can pull those down, and this will compile on your machine, and you can use it using like the bot emulator or something of that nature. So it's all there. But as we kind of start this out, we create a turn, and we have a turn context that starts. And basically, all we're doing is we're saying, okay, let's send out the main subject unless we're already in a conversation. Then we'll just continue with the subject. So that main subject basically
is a switch statement, right? It comes in and starts the subject and says, hey, what do you want to know? What do you want to do? We return a card here that pops up and says, hey, do you want to play a game or do you want to go into the granny bot? Now, the whole idea, and they told me I can't show it, was I've fallen and I can't get up, right, from like the 80s, right? So I had the YouTube up and, you know, we had some funny stuff to throw and they were like, no, don't do that. I was like, okay, whatever, that's fine. So they pulled that out. But essentially, from that, we get like a response and it sends cards up right here. And we have a lot of this kind of hard-coded at the moment. And you see we'll throw some things up here. And it's pretty simple tasks. And James is working on a pattern, basically using the rule pattern to actually refactor a lot of this code and make it a little better. Instead of using lots of switch statements and stuff, we can actually create topics as a rule and scan through that rule list and actually direct the bot where it wants to go. It makes the code a lot cleaner. So he's actually actively working on refactoring that, kind of bring it into a bit more of a kind of a production-like app. But here's kind of really kind of the meat of what we're doing here is in the startup. This is just a web app for all intents and purposes. In the startup, we're newing up the Lewis middleware, and this is where we're actually making a request out to Lewis saying, hey, here's the utterance that they gave us. What is the intent of that utterance? And once we understand what the intent is, then that's where, you know, our awesome switch statement happens here, and we jump in and actually decide on what subject, what topic we want to take the conversation down. There's ways to switch back and forth between topics within conversation. I'm not sure how much he actually implemented here, but it's pretty good. I liked it. I thought it was really nice. So let's see if I can actually get Teams going, because remember, function throws a message over to Teams using the webhook and alerts us, hey, grandma's fallen down. So I really got to be able to show that. And okay, here we go. I think it's just going to run fairly slow. While that's running, let's actually do that. I'm going to come in here, and this is the IoT Edge is an extension to the Azure CLI. Anybody use Azure CLI or PowerShell? A couple of folks, a little bit. Okay, I love it. That's where I live. As you see, I basically wrote this script will stand up all of the components that you need, and I rewrote it in PowerShell as well, so you could go either way. It will actually stand up all the components you need to run this demo, right? Because DevOps, right? I mean, it's just something we do these days.
Yeah, and one other thing I'd like to say is, you know, on the portal, the portal itself uses, you know, the Azure APIs under the hood. So I did some part of it, and then I watched Ian do it, and I was like, whoa, okay, that's definitely the right way to do it. So 2 thumbs up for the Azure CLI there.
Okay, so this is basically what I'm posting to the IoT Hub. This is the device twin that dictates everything we want on it. And you'll notice here that we have a fall equals to true. If you think back to the code, you'll know that that's where that on-desired property change, it'll flip the bit, and it'll send the 0.1. So I'm going to do that using the Azure CLI, so I don't have to do it from the portal. And I will just come and paste that in right here and hit enter. And fingers crossed, right? Demo gods are with me. And again, my machine's running horribly slow. Kind of anticipated that. All right, so we see the last message from 11:52 a.m. So now we should see another one come once that actually happens here. Hopefully it won't take all day. And on the same note, we should see a spike in Databricks when that happens.
So hopefully that has happened. There we go. Why is Teams not even showing up in my Alt tab? All right, there we go. 12:09. I'm sitting there, and we do get a message that pops up and says, hey, Grandma fell down. Let's ping the bot. So now let's jump over to the bot, and hopefully this won't take all day to switch over to my chat conversation here. And you see that I have the NDC bot right here, and a couple things to note about this. This works in Slack. Actually, Slack's a little better, or a little easier to get the bot inside the channel. So that was kind of one of the specs that I didn't get to, was we wanted to load the bot in the channel instead of having to come back out over to chat and chat. So we could just chat directly with it. You could also set up a webhook within the bot and send from the function to the bot instead of from the function to Teams, and it could initiate a conversation with you directly within Teams. So there's a couple of other options. We just kind of ran out of time to get those actually implemented. So we just did it kind of the quick and dirty way. I hope you'll forgive us there. So we open this up and we go into the main menu, and that should return our card. And that's James saying hello. Hello, James. And actually, we've already simulated everything, so let me do this. IOT Edge, CTL, stop. Just turn it off so I can get some of the resources back to my machine. I mean, this thing's pretty big, but I'm sending tons of data. So it's running pretty hot. All right, and of course, Teams isn't there. So we'll say GrannyBot is what I want to use here. And you see that it's actually sending responses back to Lewis. Lewis detecting what that is and says, okay, you want to use the GrannyBot. And then we say last alert. And this should go out and look this up and see that, yeah, it is. It's 0403 0201. That's what I have kind of coded into the function to send off to us here. And then, of course, we could send the alert. This alert actually doesn't do anything, but you get the idea, right? Then we could send an alert. So just kind of an interesting use case. Now, you might ask, why did we choose the technologies that we chose and all of this? Well, I think it's very scalable. The last piece of this, of course, is Lewis. If we came in here and we look at the V4 reference app that he set up, we actually thought it was this NDC GrannyBot demo, and we like retrained it with some of the utterances that we're expecting me to type while I'm on stage, and then I'd go back over to the bot and it wasn't there. Trying to debug when you're not using the right endpoint drives me nuts, right? You know, that's a good hour of my life right there. He was like, oh, wait, no, that's the wrong endpoint. And then he added this to my AI here, and yeah. Then once we train this bot, we could actually talk to it. So I could do more or different utterances like, what did I type? Latest alert, you know, it should return quite a few things. It might not because, yeah, okay, there we go. So we're still in the right topic and everything. So there's different utterances. If I could pull it up and on my machine, she's just taking her time. But anyway, I think that's where we're at. I think we showed a successful demo. Everything works. I've built this type of lambda-based architecture for IoT for about 4 or 5 customers now using IoT Edge. Of course, it's in preview, so they're not in production yet. But we do have devices on assembly floors and out in fields and in cars, what else? In refrigerators deployed. And Anu had mentioned, it does watermarking for late arrivals and out of order stuff. And when you're dealing with IoT and IoT devices may go offline for a while, depending on what your solution is. If it's in an offline state for a month and then it gets connectivity via cellular or something of that, RF, whatever, and it starts shipping data for you, this is late arrivals. This is out of order. You need to be able to handle that type of stuff. And in our investigations with our customers, we've used a bunch of different technologies here, and Spark seems to really kind of land very well and fit that bill, where it gives you the most flexibility to handle those types of asynchronous data wrangling scenarios when you're doing any type of ETL or rules engines or anything like that. I literally rewrote a rules engine for one of our customers 5 different ways to test this between the product teams, and actually went up to Scott Gu and talked to them about Stream Analytics and where they need to go to fit Stream Analytics into this. We do deploy Stream Analytics on the edge. On the edge, it works great because for the most part, things are going to be ordered, right? Because the device is there. Even if it's in an offline state, the edge is what enables the offline state. So doing the processing on the edge using something like Stream Analytics was great. And we're successfully doing it with like 20-minute windows and things of that nature. But once we put Stream Analytics in the cloud and extended the windows and things like that, things got a little bit more difficult. So if you have very complicated type of rule sets with sliding windows and you can't guarantee the order of your data, then you really need to come in and look at something like Databricks or something to that effect, is kind of what we found. All right, so I think we're good with going into the Q&A. Sorry about my machine being slow. I typically use a Linux box. My main machine is a Linux box, but the functions, the V2 function had a problem with event hubs, so I had to go back to V1. And V1 is .NET Full Framework, not .NET Core. So that's the only piece right now that I need to kind of fix so then I could do this. I wanted to do this demo for my Fedora box, but there we are.
I just want to say one last thing, right, before we jump into Q&A. This is how I look at the world, right? You can read all the manuals on how to drive a car, but until you get in that car, turn on the ignition, hit the pedal, you don't know what it's going to do, right? So Ian's actually, uploaded all the code up in the, in the Git repository. I would say after you go out of the session or, sometime during the day, during the week, pull it down, start playing with it, and hopefully, we've generated enough ideas here that you're able to take this back and, apply it to your worlds. All right, what questions do you have?
At Build, they showed a couple smart IoT buttons devices. Where can we get our hands on devices like that, or are there like certain classes of devices that can run Edge?
Was that Cecil doing that? Yeah. So I believe he bought those off of Amazon and just took them up to Azure Functions. Yeah. We were presenting, I think, at All Things Open, and I pulled him on stage to show some of that stuff off, which I thought was really cool. And he said he just got it it's just a IoT button that he bought off of Amazon that you can program. So, yeah.
But it has to be capable of running Edge, right?
Did they have the Edge buttons?
Well, that was the first day.
I think there are Edge certified devices. I remember seeing something around that. Have to go look.
My guess is that they made that button talk to an Edge device. So we didn't get into a lot of the different gateway type of scenarios, but Edge device can work as a gateway. So you don't have to run Edge on a device. Like one of our customers, they're running it in store on VMs. And then all of the devices are just talking to that, and it's doing protocol translation as well as identity translation. So, yeah, no, good question. Any other questions? Excellent. Well, we'll give you a minute back. I hope you have a great conference, and come by and see us at the booth. Green cards, yellow cards, red cards in the back. Remember to kind of score us there. And y'all have a great day. Thank you.
Thank you.